Hello everyone, we are from Group 6. Today, we are going to present about one of the worldwide fatal major industrial accident in human history, which is the 1986 Chernobyl nuclear power plant accident. Nuclear energy is a form of energy released from the nucleus, the core of atoms, made up of protons and neutrons. This source of energy can be produced in two ways: fission, when nuclei of atoms split into several parts, or fusion, when nuclei fuse together. Next is the history of Chernobyl disaster. Chernobyl disaster, accident in 1986 at the Chernobyl nuclear power station in Soviet Union, the worst disaster in the history of nuclear power generation. On 26 April 1986, the number 4 reactor at the Chernobyl nuclear power plant in what then was the Soviet Union during improper testing at low power resulted in loss of control that led to an explosion and fire that demolished the reactor building and released large amounts of radiation into the atmosphere. As safety measures were ignored, the uranium filled in the reactor overheated and melted through the protective barriers. Next, RBMK and its unique features. RBMK is a Soviet-designed nuclear reactor that used enriched uranium as its fuel. It is a rather unusual design as it uses graphite as its moderator and was designed for plutonium production, but was also used extensively for electrical generation. The combination of graphite as a moderator and light water as coolant is unique to this reactor, as no other reactors in the world use both. The RBMK is famous as it was the ill-fated reactor involved in the Chernobyl disaster. As the disaster showed, the RBMK had some key design flaws. In particular, the location of the control rods, the containment structure, and the reactor's positive void coefficient proved to be quite unsafe. Since the disaster in 1986, the remaining RBMK reactors in use had some significant design changes to address these problems and ensure safety in the future operation. RBMK reactors operated for decades in Russia after the Chernobyl disaster.
So I will continue to present the timeline of the Chernobyl disaster. At April 25, the day before the explosion, Reactor Unit 4 was scheduled for a safety test to evaluate its ability to provide emergency power during a power outage. The reactor power was reduced from the stabilization state 70% to 50% perform the test, but an unrelated delay disrupted the process and hence leaving the reactor in an unstable stage for hours. At the late evening, April 25, the operator reduced the reactor's power, but it dropped too low and causing the instability. In attempt to stabilize it, the operator will respond by removing most of the control rod in violation standard safety protocol and yet increasing the risk of the uncontrolled reactivity. At the April 26th, which is the test began and also the explosion occurred, the operator initiated the safety test by turning off the turbine generator, simulating a loss of power, and the cooling water is flow decreased as a result, causing the reactor core to heat up rapidly. And hence a positive feedback loop in the reactor design is increase the reactivity. Explanation of the explosion and immediate aftermath. Trigger of the explosion. When operator attempt an emergency shutdown, the graphite tip control rods initially increase the reactivity. This flow will cause a sudden and a massive surge in reactor power, and the explosion is a steam explosion occur, rupturing the flow channels and busting off the reactor's core. A second explosion, likely caused by the hydrogen buildup, destroyed completely the reactor building. Radioactive material was ejected into the atmosphere. Immediate aftermath, releasing the large amount of the radioactive material into the environment. Workers and the firefighter was exposed to the lethal radiation level. The radioactive cloud began spreading over nearby areas, including the Pripyat. What is the key technical failure that contribute to the accident? One of the major design flaws of the Chernobyl nuclear power plant was the use of the RBMK 1000 reactor. The most notable flaw was the positive void coefficient, which means that as the steam replaced the water in the reactor, reactivity increased and create a dangerous feedback loop. Furthermore, the control room consists of the graphite tip, which means the reactor lacked a robust containment structure, allowing the radioactive material to escape. Second, inadequate training. The operator disregarded the safety protocol and lacked the knowledge of the reactor's specific vulnerability. The third one is the delayed response. The plant official downplayed the severity of the incident, delaying the evacuation and containment effort.
For this video, I will be talk about immediate consequences from the accident. Firstly, 2 plant workers died on the night of the explosion. Second, 28 emergency responder and plant operators suffer from acute radiation syndrome. Thirdly, approximately around 116,000 people were evacuated from 30-kilometer radius around the plant. Second, impact on plant worker, firefighter and first responder. As I mentioned before, 2 plant workers died in the explosion. Firefighter exposed to radioactive debris and smoke due to damaged reactor. Thirdly, first responders such as police and medical personnel exposed to radiation doses while treating and assisting the injured. Next, I will be talk about the initial containment effort. The effort is the sarcophagus construction. The purpose of this construction is to prevent further release of radioactive material into the environment. The construction process began in May 1986, weeks after disaster, and completed in November 1986, and the construction consists of concrete and steel panel built to minimize worker radiation exposure. Next is the challenges and limitation. The challenges and limitation is that it was built under extreme condition. Workers who built this construction often exposed to high levels of radiation. The effectiveness of this sarcophagus construction is that it managed to reduce radioactive emissions. Lastly, I will be talk about short-term environmental and health effect from this accident. First is the environmental effect. Radioactive fallout spread across Europe. Farmland, forests and water were heavily contaminated. Wildlife, farm animal and also livestock experienced immediate radiation sickness, genetic mutation and death. Second is health effect. Plant worker and first responder experience high doses of radiation. Nausea, vomiting, skin burn, and hair loss are one of the health effects. Some severe cases led to internal organ damage and death. Lastly, crops, milk, and water were contaminated with radioactive material. Consuming this can pose immediate health risks.
To present about the accident Chernobyl on 1986. There was several impact for the 1986 Chernobyl nuclear power plant accident in the Roman time period. For first, they have a consequence to the environment, such as the radiation spread to the environment that was including some harmful materials such as sulfur-137 iodine and iodine-131. And the exclusion zone also occurred due to the harmful material content in air, water, and soil. So it also led the living space of human being compressed. Besides, some of effects from social is most influence to the crowd. Over of 300,000 people will lost their family, homeland, and this lead the cultural tired will affect and obstruct the development of the world. And this of survival will face some social problems such as often being labeled as contaminated and facing discrimination by someone. For next, they have some health effect of the population. The risk of cancer and long-term health issues was increased. Some of health problems also occurred from the perspective of mental and the symptoms such as anxiety, depression, PTSD, which is post-traumatic stress disorder, and these of symptoms will accompany along their life. Other than that, 1986 Chernobyl nuclear power plant also make economic loss in clean out and rebuilding because more energy needed in containment, clean out and rebuild the building destroyed, and its impact in agriculture and this industry also being serious due to pollution of water and soil lead
agriculture and industry drives their economy, sources, and need more time to rebuild their economic system. Lastly, some of regency and lesson was learned from this accident, and this already known by population by using movie and say sorry and know about the dangerous effect of nuclear use.
We will be proceeding with the current status at Chernobyl. Now, as of February of 2021, there are few progress and changes around Chernobyl. One of them is the Chernobyl exclusion zone, which is a zone with a 30-kilometer radius from the center of the reactor, remains off limit due to the radiation poisoning, and though some wildlife like deer and foxes are returning slowly towards the exclusive zone. Next, the reactor of 1, 2, and 3 are in complete shutdown, while the reactor 4 sealed in a new safe confinement or NSC, which is a semicircular cylinder that is made out of steel. It was started around 2010 and completed around 2016. Next, the radiation level decreased over time, but it is still dangerous. This is because the half-life of the radioactive material around Chernobyl takes up until millions of years. So there are limited access for short visits. Next, the sarcophagus and the NSC contains reactor 4, ensuring no radiation leakage up to 100 years. Next, scientists are gathered around the Chernobyl to study the ongoing effect of nuclear radiation or radiation in general towards a living organism such as humans and animals. Other than that, there are booming of tourism around Chernobyl, especially at the abandoned city of Pripyat and the Red Forest. Also, there are the decommissioning of the nuclear reactor 1, 2, and 3 for the safety removal of the fuel, and the dismantling continues for those three reactors. Now, the radiation decay will continue for a century with full recovery expected in the distant future. We might not know when, but it will be recovered. There are a few things that we can conclude from this incident. One of them is we need to ensure the proper safety protocols needs to be followed properly to avoid similar mistake in the near future. Next, reactor design must be thoroughly tested for safety, as flaws can lead to massive disaster such as this one. Other than that, government and authorities must ensure a clear communication during crisis to avoid panic and misinformation so that the accident can be contained more securely and more properly. Last but not least, the long-term environmental and health effects of radiation are severe and last for generations.